Hello, my name's Paul Roberts and I'm a chemistry teacher here at Andover College. Today we're going to be looking at the core practical, measuring reaction rates by monitoring different gas volumes. The reaction in particular we'll be looking at is between hydrochloric acid and calcium carbonate in the form of marble chips. The products of this reaction will be water, calcium chloride solution and importantly carbon dioxide gas. I'm going to show you some tips along the way how you can get good, clean, representative results. In terms of safety, we're going to be using 1 mole of hydrochloric acid. At this concentration, it's important that you'll be wearing safety glasses and a lab coat. Any spills of the hydrochloric acid on the table or on the skin should be cleaned up immediately with plenty of water. At the end of the reaction, any unused hydrochloric acid can be disposed of down the sink with plenty of water. It's important that you don't put the marble chips down the sink as it is likely to block the sink and this won't keep your technicians happy. Before you start the practical, it's important to get a good delivery tube and bung set up. Otherwise, gas will leak out of the system, giving poor results. Select a bung that is an appropriate size for the conical flask. If the bung doesn't already have a hole in it, use a cork borer to make a hole of the correct size. It's important this hole isn't too large, otherwise carbon dioxide gas will escape around the sides of the delivery tube. Now carefully push the delivery tube through the bung. Make sure you do not apply too much force and keep your hands as close to the end of the bung as possible. This will reduce the chance of the delivery tube breaking. You only need to push the delivery tube a few millimeters through the other side of the bung. You can now check if the bung delivery tube setup is airtight by placing the other end of the delivery tube in water and then pushing the bung into the conical flask. At this point you should notice a few bubbles appear out of the delivery tube as air is displaced from the conical flask. Assembling the bung delivery tube setup is something that should be prepared before the practical. I would suggest matching the delivery tube setup with a conical flask, as small variations in size can lead to poor fits. Next, we'll assemble the gas collection apparatus. Take a 100 centimetre cubed measuring cylinder filled almost to the top with tap water. Next, choose an appropriate sized bung, insert this in the measuring cylinder and invert the measuring cylinder. Now, place the lip of the measuring cylinder below the water line in the trough. The measuring cylinder now can be clamped in position. It is at this point where students are likely to encounter spillages. So I would strongly recommend keeping any paperwork, calculators, and especially electrical equipment away from this part of the practical. At this point, it's worth noting that the level of the water in the trough must not be too high. Otherwise, when the water is displaced from the measuring cylinder, water will overflow from the trough. We are now ready to start the practical. Pour 40 centimetres cubed of 1 mole per decimetre cubed hydrochloric acid into a measuring cylinder and add this to the conical flask. Have ready a beaker of 5 grams of marble chips. These can either be weighed in advance or be prepared by the students. The mass of these marble chips is not crucial, as the calcium carbonate is in excess in this reaction. The reaction is likely to proceed at quite a brisk rate, especially with the concentration of 1 mole decimetre cubed hydrochloric acid. Therefore, before you start the reaction, have the stop clock ready, zeroed, and also have a suitable table of results ready to fill in. Make sure the end of the delivery tube is inserted into the measuring cylinder. Holding the bung in one hand and the marble chips in the other, pour the marble chips into the hydrochloric acid and immediately bung the conical flask. Only start the stop clock when you see the first bubble hit the top of the measuring cylinder. This will produce better results as it will take time for the system to pressurise and the water to be displaced from the delivery tube. Measure the gas volume every 30 seconds by reading the measuring cylinder until the measuring cylinder is full. If a lot less gas was recovered, one of two things could have happened. Firstly, there was a long delay between putting the marble chips into the conical flask and the conical flask being bunged. Secondly, there is a gas leak in the delivery tube apparatus or around the conical flask. Now the reaction is over, the bung can be removed from the conical flask and the delivery tube removed from the measuring cylinder. The measuring cylinder can be removed from the water trough, refilled with tap water and replaced for the next experiment. The contents of the conical flask can be poured down the sink, taking care not to pour any marble chips down the sink. Now the whole experimental setup can be repeated, this time using a different sized marble chip or a different concentration of hydrochloric acid, depending on which independent variable you're choosing to investigate. After you finish this experiment, you will have generated some data. This data will need to be analysed in a graph, and when you're plotting your graph, make sure you look out for anomalous data and take care when drawing your line of best fit. So in summary, we've carried out the reaction between hydrochloric acid and calcium carbonate in the form of marble chips. The reaction has been monitored by measuring the gas volume of carbon dioxide produced. This will now enable you to investigate how the size of the marble chip or the concentration of the hydrochloric acid will affect the rate of reaction. And finally, we've carried out this reaction in a safe and secure manner. Today we're going to be looking at the core practical, measuring reaction rates by looking at a colour change. The reaction we're going to be looking at in particular is hydrochloric acid reacting with sodium thiosulfate, which will produce sodium chloride, water, low levels of sulfur dioxide and sulfur precipitate, which will give us our colour change. You're going to be carrying out this reaction at different temperatures and measuring how the temperature change affects the rate of reaction. This is a classic chemistry experiment, and I'm going to show you some tips along the way where you can get some good, accurate results. Regarding safety of this reaction, we're going to be handling 2 moles per decimeter cubed hydrochloric acid. It is therefore essential that safety glasses and lab coat are worn throughout. Any spills of this hydrochloric acid, either on the bench or on the skin, should be cleaned up immediately with plenty of water. To ensure minimum disturbance from the sulfur dioxide, this reaction should be carried out in a well-ventilated laboratory, and immediately after the reaction is finished, the contents of the flask should be disposed of down the sink with plenty of water. For further advice, please refer to CLIAPS. In this core practical, you will carry out the same reaction at a range of temperatures you have chosen in advance. However, in this demonstration, I will only carry out the reaction once at a temperature of 30 degrees C. To start off, set your water baths to the desired temperature. The water baths reaching their temperature is the part of the practical that is likely to take the longest time. You can also obtain required temperatures using conical flasks in water baths above a Bunsen burner. If you choose this method, the practical is likely to take a little longer. Whilst the water bath is reaching the correct temperature, clamp a 250 centimetre cubed conical flask in the bath. Resist the temptation to stand the conical flask in the bath, as it will likely tip over. Now, using a 10 centimetre cubed measuring cylinder, measure out 10 centimetres cubed of 0.25 moles per decimetre cubed sodium thiosulfate and add this to the conical flask in the water bath. In a separate 50 centimetres cubed measuring cylinder, now measure out 40 centimetres cubed of distilled water and add this to the conical flask. Now, using a clean 10 centimetre cubed measuring cylinder, carefully measure out 5 centimetres cubed of 2 moles per decimetre cubed hydrochloric acid. Pour the hydrochloric acid into a test tube and place the test tube into a rack in the same water bath. I suggest using a metal test tube rack, as wooden ones will likely float. It is important that the levels of the hydrochloric acid and sodium thiosulfate are below the water line of the water bath. This will ensure stable temperature of the solutions. Whilst the reactants are heating up in a water bath, prepare the next part of the experiment. The method we're going to use to monitor the reaction is to time how long it takes for a cross to disappear when viewed from above. Using a thick black marker pen, mark a cross on a piece of paper and place the paper inside a clear plastic envelope. This way the wet conical flask won't smudge the ink. Alternatively, you could place a mark on a white tile with a permanent marker. After 5 minutes of the solutions heating in the water bath, the thiosulfate and hydrochloric acid solutions should be up to temperature. It is worth comparing at this point the temperature of the actual water in the bath and the temperature of the sodium thiosulfate solution in the conical flask. These temperatures should be within 1 degree C of each other, confirming that the reactants have reached the desired temperature. Do not use the temperature setting on the front of the water bath, as this is approximate and likely to be unreliable. The temperature of the thiosulfate solution should be recorded at this point, as this is the temperature that the reaction will take place at. If you are happy that the temperature is stable, you can proceed to the next stage. It is important that the next stages are done promptly, as when solutions are removed from the water bath, they will start cooling. First, remove the conical flask and place it on the cross. Immediately add the hydrochloric acid to the conical flask and start the stop clock. Swirl the flask for a few seconds to mix. Place the flask on the cross and look directly down the conical flask at the cross. When the cross can no longer be seen, stop the stop clock and record the time. Now the reaction is over, the waste solutions should be disposed of down the sink with plenty of water. The conical flask can be rinsed, thoroughly emptied and used again for the next reaction temperature. You can now repeat the experiment for at least 3 more temperatures. These are the temperatures that you have chosen in advance. And at the end of the investigation, you should have a range of times taken for the cross to disappear at a range of temperatures. Your teacher will then show you how you can analyse this data to determine the rate of reaction and plot appropriate graphs. So in summary, we have carried out a reaction and monitored the rate of reaction by observing a colour change. We have seen how to collect accurate and reliable results, and we have disposed of the reaction in a safe and prompt manner.